Hi, in the last session, we talked about functions and procedures in VHDL. We learned how to use them and where to use them. We discussed that how these VHDL functions and procedures can save your valuable time and efforts when writing and maintaining bigger VHDL codes, which are using reusable elements in your designs. Now let's talk about packages and libraries in VHDL. So let's start. Okay, so what are these VHDL packages and libraries? If you remember from our previous sessions, we have touched upon a few packages like numeric underscore std package and std underscore logic underscore 1164 package, etc. So the primary purpose of these packages is to share the commonly used items across multiple designs. These items can be anything. It can be declaration, it can be data types, it can be mathematical or logical operations, etc. Means everything is defined there and you can use its elements anywhere in your designs without defining them across your multiple projects. You just need to include those particular libraries and packages in your VHDL design, and that's it. And you will get the access of all of its elements. In most of your designs, you are going to use some very common packages like std underscore logic underscore 1164, numeric underscore std, etc. because they contain most of the commonly data type definitions, functions, and features. If you are familiar with C or C++ kind of software programming languages, there also you generally add headers in your codes. So you can think of VSL packages just like the header files in the C or C++ language. In both cases, you declare definitions, data types, and functions, and many more things that can be shared across your multiple VHDL files. And just by adding those packages, you will get the access of all of its contents in your designs, and you can use them wherever they are needed. Okay, so what are these packages in VHDL? A package is a collection of signals, constant, data types, subdata types, functions, procedures, components, files, and attributes. And once you declare a package in your VHDL file, then all of these items which are defined in that package become available to you for your designs. In our previous session, we generally used std underscore logic underscore 1164 package to use the std logic data type. Similarly, we declared std underscore numeric package to use signed and unsigned data type. This is because these data types are defined within these specific packages. So this is the importance of packages in VHDL. And interesting thing is that these packages are not only predefined packages, but you can also create your own custom package. So let's explore how to do this in the next slide. Let's take an example of traffic light. We discussed this in our past sessions, so it will help you in better understanding. But a quick recap. So we created a custom data type called T-light type with the possible states red, yellow, and green. So here is the declaration of this data type. Additionally, I declared a new signal called traffic light using this custom data type. So we need to use keyword type for creating our own custom data type. We explained this in our past session, so you can refer that if needed. In that session, we defined our data type definition and signal declaration between the architecture declaration and begin keyword. These multiple dots indicates that you can add more signals and data types if needed for your designs. So you can add all of them here. So in VSDL, we simply write this as architecture, architect 1 of entity 1 is type, T light type is red, comma yellow, comma green, semicolon, signal, traffic light, colon, T light type, semicolon. Then begin. Now suppose I want to use this custom data type, T light type, to create the necessary signals for my designs. And I need to use my traffic light data type as two separate VHDL files. In this example, the first code is in the top VHDL file and the second code is in the bottom VHDL file. So we have two different VHDL files for two different projects. So in both files, I had to declare this tlight type in both the files individually if they are going to be used in these projects. So in each file, we declare this tlight type data type, followed by the signal declaration using this data type. This approach of defining the elements in each individual file works completely fine, but it is a painful approach and it is time consuming as well, especially when you are using these designs in many projects because you are declaring them in each and every file. Now, suppose you are looking for some modification on this data type definition based on some project demand or because of some future needs or improvements. Then you will have to modify your data type definition in each and every file individually, which is time consuming and that leads to the more human errors too. For example, you wanted to add a new color to this traffic light. Say you want a fourth color on it, like white. Then you will need to update this in each and every file, which is using this data type. Now suppose you have hundred of files where it is being used. So you can feel that this process is actually time consuming and challenging too. So in these type of situations, packages can help you to avoid such problems. So let's see this in the next slide. Here I have created a simple package called my package using the package keyword. Inside this package body, I have declared our tlight type data type just like before. So my VHDL code for this package definition is package, my package is type, tlight type is red, comma yellow, comma green, semicolon, and my package, semicolon. And that's it. I included tlight type in my package. Note that once you finish your package definition, you need to terminate your package. So we terminated it with the AND keyword. Although I can add more declarations to this package. But for our requirement, this is enough for now. Now I saved my package as a VHDL file with a .vsd extension. Note that both packages and VHDL file has the same .vsd extension. So now let's see how we can use this package in our design. So in the bottom section, we have two separate VHDL files again. In order to use these packages, we need to declare the package first. So it is declared at the top of each file. I have marked that with the yellow arrow. So packages are declared at the top of each VHDL file. To declare a package in your VHDL designs, we need to use keyword use followed by the library name dot, then write the package name dot all semicolon. So we use the keyword use to declare this package. As you can see here, we have written use work dot my package dot all semicolon. We have written this in both of these VHDL files as you can see. Note that here work refers to the library where my package is located. It is a special keyword indicating the current working library. Always remember that when referring to a package, use its package name, not the file name. These are two different things and they can be different as well. Once you declare this package, you can use traffic light data type to create your signals in both of these VHDL files. And you do not need to define it again in your VHDL files. In case you wanted to modify your data type, such as adding a new color like we discussed, then you simply need to change it in the package file. And that's it. Now you do not need to change it in every individual VHDL files in your projects. Okay, so that's it for today. That was a quick and concise overview of VHDL packages. We learned how to create a simple package and how to declare it in a separate design unit. We also discussed why we should use packages to share declarations across multiple design units. In the next session, we will be talking about VHDL libraries. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.